Hello, hello, hello. We'll get started. I hope the volume is fine. Let's do this. And it should be alright. I don't know if the volume is like really loud or not, so I'm just gonna listen to myself a little bit probably. But yeah, 2 seconds. Boom. Let's do this. Oh, it's actually kind of fine. It should be alright. Yeah, it's actually fine. Okay, it's time. So I actually did a lot since Friday, because Friday was the last time I streamed some game development. Then there was like the weekend. I had my tests, my Japanese tests. That was very simple actually. And what else? Yeah, so I have to tell you about what I did, right? Wait, I feel like that's gonna be a bit too loud. Okay, let's hope that this is fine. Okay, so, last time what did I do? Well, let's play the game and you're gonna see. So right now we have this, okay? And as you can see, we don't have the problem anymore of like the ground just, you know, cutting itself, you could say. And there's actually a few reasons for that. As you can see, things work kind of alright. Well, okay, we have two faces that intersect each other, but that's normal because they're at the same place. And yeah, and we have just the donuts that's being generated. So what did I do? It doesn't look like I changed things too much, right? But actually, I modified... Well, the first thing is like the transformation. If we go in... Let's go there. There. No, not there. In the torus. We have the transformations, right? And at first, I was basically... I had this distorted vertex. And I had the normal vertex. Position of the normal vertex. And I was just basically doing... this and this. I was basically just doing this. But the problem with that is that it well, can I maybe just show it? Unknown, distorted. Yep. So maybe something like this. Okay. Brainport. There. Okay. Okay. So now we can see it. Yeah, we can see that we have some problems there, right? We have like the ground that's clipping through. We have some chunks that are behaving a bit weird. And when you go up, it's not a problem anymore. That's why I didn't see it right away, right? It's not like a problem. Only when it's like really down and when you have a lot of space. So I'm glad I saw that, thanks to this generation bug, you could say. And the reason is actually very simple. The reason is because we have blocks here, right? But these blocks are actually not supposed to be cubes. They're actually supposed to be... 2 seconds. So when I just don't use this and return directly the world position of the vertex, you're gonna see that it's actually very, very, very small blocks like this, right? Rectangles. Like very, very small rectangles, right? And this is a problem because the thing is, if we interpolate the world position as if it was a cube with the world position as if it was a rectangle, then, I mean, of course, as a rectangle, since they are very small, then the rectangle is going to be a lot closer to me, right? And that means you have those cubes that take a bunch of space that are interpolated with the position of the rectangle that is very close to you. So that's causing like some problems that, you know, it's like not transforming the cube back to normal, to its position, to its normal position. But instead it's like doing some weird thing, right? So the idea I had was, instead of interpolating the two positions together, we're just going to push. We're just going to push that. And my first idea was to have actually some kind of limit with basically if the distance, what was it again? If the length of the distance if the distance between the camera and the vertex in chunk space is like less than 10, then I'm going to return chunk space, the distorted one, right? And if not, I'm basically going to return this just this, right? I'm basically pushing the vertex in that direction. I mean, I guess I can just copy this. Yeah, it's very long, I'm sorry about that. So basically just this with something like, I think it was this, and we didn't have the alpha, so probably something just like this, right? So if it's like higher than 10 for the distance, then we get the position of the camera, we normalize the direction, we multiply by 10 so that we can push the vertex outside of the range of the Euclidean area. And then, we add the basic length of the... Wait. Plus length of camera to vertex. Maybe it was more... Yeah, it was more something like this, right? Yeah, because we also have the same like below. We have the plus inside the parenthesis, because we want this to be multiplied by the direction. Because, like if we have a cube far away, then we want to push it far away, right? We just want a little offset with it. So that was basically my idea, and it worked well. And I just basically, after that, modified things a bit more to interpolate, right? Because it wasn't an interpolation. Let me actually show you what it gives us. Oh, wait. Never mind. But yeah, it basically gave some kind of platform, but you had like a strong tinge. Like a plateau, you had a plateau. But now it's not the case anymore thanks to the interpolation. Since we interpolate like this. And the distortion is a bit different. Oh, we have to re-import. The distortion is a bit different, but it's working well. Like locally, it's like the right cubes. And as you can see, like when I move this way, for example, it looks like the chunks are kind of like rotating towards me. Like the blocks are kind of coming to me in a weird way. But in the end, everything is like a cube over here. And like over there, I can put some blocks. And when I go closer to them, you can see that it's, correctly coming towards me, which is nice. We have some problems with like the frustum culling, but I'm going to talk about it very, very soon. Okay, so basically that was the first thing I did. Other thing I did is I basically profiled a little and noticed that we can actually see it right there, debugger. I registered a monitor, a custom monitor, and as you can see, we can see the amount of chunks that are killed and the ones that are not. And this is like very useful. Because for example, when I go there, we can see that almost no space is going to get culled, right? But when I look away, now you have almost every chunk is getting culled, right? And this is very good for performance, like, you know, reducing draw codes and stuff. And it wasn't working before. And there was actually, it was a very simple, well, I'm gonna show you where I registered the monitors. Register, custom, monitor, somewhere. Monitor, here we go. I just have this. It's basically just this. I just have some, I guess some getters, you can say. And then I'm just setting those variables, just updating them in the first time encoding, right? And for the first time coding, I actually, I guess I stopped the stream just before actually using it, while succeeding in it, right. So actually you didn't even know when the first time wasn't working. But basically all I did is I looked into the engine's code and I discovered this class, well, two classes actually, FrostM and instance bounds from the renderers in curl. And you can actually just reuse those classes. There's like a constructor taking the FrostM and another taking an AABB. And then you can just use this function to test if it's inside the FrostM or not. So it's good. So I just used this and it worked. Well, it didn't work at first, and the reason was because CubeChunk Visual here, I wasn't updating the transformation correctly. But yeah, that's it. And yeah, I think when I was trying last time on stream to do the first time, I basically forgot that there was that I had to apply the donut transformation to the vertices. So I did it, and that's it. I guess I optimized a few other things. Like for example, I removed the colors because it was taking a lot of performance, I guess. And you know, the colors there, right? And I also updated the normals a bit differently, so I could compute them only like one time for like every vertex of the face. Okay, what else? Yeah, I guess I just added a few macros. I mean, I guess I can open Tracey right now. Tracey profiler. I'm a bit curious about what it says. So let's go there. Let's say we have, oh no. No! Very bad. I think it's wrong. Okay. So if I do this, is it good? Now I'm gonna stop. I only have basically Tracey there. I'm just not sure whether it's actually doing things or not. Oh, it seems like it is. Wait, add frame delay process. No, it's not. I think it takes the editor, maybe. Yeah, editor. Let me just restart. Maybe. This. Okay, here we go. So we have a bunch of stuff. We can try clicking a little bit, you know, creating some, well, regenerating some chunks, I guess. And now we can go back, tap, and we can see the performance. So what I did is I added some macros. I mean, we already did that before, so I'm not really gonna show it. But I added some macros to show a bit more what was taking performance. So like the generation, for example, is this. Generating the vertices is this. You have the batch transform for the donut, and you have computing the normals. I don't know why it's taking so much, but it's there. With 10, well, 11 milliseconds. Wait, that's so much. But yeah, the goal is to move that on the GPU, so it's not that much of a... It's going to be a bit troublesome, but that is fine. And then we have the rendering part that has like a lot of chunks getting rendered in Drawpack, right? Yeah, and it's like taking a lot because we have just so many objects. Because I guess we can go to like 2,000 chunks, something like that. And the first time is like really small in comparison, so that's why it's like interesting to make it. Yeah, I would say that's it. The Kendra pack is actually pretty heavy. I don't really know why. Wait, why? Can draw pushback. Is it because of is empty? What the fuck? Is it because I have that many chunks? Can I just? Is it because of the vector? Because it wasn't reserved? No, I do reserve it. Wait, that's crazy. I reserve it and it's so slow. I'm not sure about that. It's the virtual function, maybe I was thinking, but like when you look at the first time, the first time is actually taking. No, it's taking a bit more, but I guess it's just looping through all of those objects. That's like so inefficient. Then we have multiple generations there. But yeah, I would say that's, that's it. So it's like it's not really performance right now. But I mean, it's good enough, right? We have like enough frames. I limited my FPS to 30, that's why we had like the big weights. Okay. So now, wait, 1, 2, 1, 2. So it's maybe a bit loud. Maybe something like this. Maybe it's a little bit better. I'm not sure. Okay, then we have different things to do. We have... Okay, so rendering the chunks around the player first. So... right. Let me go up. Oh, not up. To do... Actually, yeah, I have a to-do file. Let me go there. So this is fixed. Like face coding. What is that about again? I don't know. Generate chunks the player is in. Generates neighbor chunks that are... Let me just copy all of that to the to-do. Okay. So what did we have first? Generate chunk visuals one progressively around the player. So we have to make it around the player and that should be it. And then we have the collisions. And then we can actually start having our game. So for that, let me go there. We have the observer. Wait, it's actually in 0, 0. Let me... I'm actually not sure about this. Visual. So it's the simulation group, okay. Visual loader, player observer. Here. Add observer. And I guess it's like no, this one doesn't have, well, observers don't have the rendered position, so that's fine. Get current chunk. Yeah. Right. Right, it's actually a bit tricky. Then we have chunk to spawn from. And it's the one we are spawning from, I guess. Right, but we have to update this, right? We have to update it depending on the observers. Or do we? Well, actually, we spawn one chunk first, then we step, then we have chunks to spawn from, and we try to load them, right? Which is fine if we want to generate from something, but yeah. So whenever it's changing chunks, let me think. I'm actually not sure. And I mean, I think I should, well, find a way to continue generating if the chunk already exists or something like that. I don't know. Anyways, so for now we have this chunk to spawn from, index, remove. Okay, so it's a pop. No, it's a, well, pop first, pop front. There. And if I want, hey, Azrato, hello, how are you? How are you doing? If we want the generation to move along the player, so basically we can do multiple things. We can change priorities, or we can try to add things to the list again. I'm fine, I'm fine. I'm finishing a project. Oh, which one? Bardanza? Neighbors. So for every neighbors we do things. It's filling. Is hiding neighbor. Build chunk ID. Okay. Yeah, I don't like those callables, but for now that's fine. Then we request. If it doesn't find. Yeah, okay, this function is kind of slow. Nope, the Cité des Îles to the sky. Oh, nice. Sounds nice. Can I make something a bit more efficient? Because I guess the default way to do things would be to just loop through a grid and add the ones that are near the position. But the problem is that with a non-Euclidean space, we can't really take like random coordinates and, you know, the stuff. Because we don't really know which chunks are what would be the same from the connections. Yeah, it's a big problem. Well, it's me overcomplexifying things, I guess, for the future. That's fine. We can always make a special case for cubes, for example. For now, I'm just gonna keep this. And let me think. So we request label. Okay. Wait, I'm not actually removed. No, that's fine. So I guess what I can do is something like when the observer is moving on new chunk. Let's do that. On new chunk. Or is it? Am I? Well, I have multiple observers. And there are my DF. Who's put me to do the dishes? Oh no, dishes. That's a BF. Not the best friend. I mean... Okay, so we have observers. We have the on new chunk on observer new chunk. And this is gonna get called when an observer changes chunks. So let me put that in private. And it's gonna have a reference towards the observer, of course. And it's gonna have the new chunk, maybe? Maybe the old and the new would be nice for the event. Let me think. Basically, I'm just afraid that it's gonna restart the whole generation, like everything. So I'm not sure about this, but yeah. We can also sort things again. Well, let's sort the chunks depending on that. I guess depending on multiple players, we can... Well, actually, there's only one observer for the visuals, so it should be fine. Anyway, we have the old chunk, we have the new chunk, and we can have a little function there. Well, almost. Sorry, I'm very tired today. I kind of changed rhythms a little bit. I don't know how long I'll be able to last, but let's stay motivated. So when we do this, can I clear and do a loader.clear? No. Whip chunk IDs. I guess that can stay. That can stay to generate, and then I guess we have to request a lot of new chunks, like the current one. Yeah, just the current one is good. Always generate the current one. So something like this, basically. Yeah, it's not changing anything. I guess that would be a start. I mean, I guess I don't really have to remove those already there. And I do need a sort, but yeah. Let's try this first, maybe. Well, we need. I don't know if I'll be able to do much tonight. I'm so tired for some reason. Maybe I should go stream tomorrow. But At least 1 hour. And okay, let's do this actually. Let's say that we're just gonna do this. So so we have the observer, and when the observer, okay, so this is good. When this is on new chunk, how is it called? It's not. I mean, I guess it's like a signal that I have to declare in Godot. Godot signal CPP. Right, so we have the method. It has the custom signal, add signal. And then we have another one with arguments. So wait, what is this one? Callbacks methods, so Godot can see them. On timer. What? 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 Why? I don't even know why I'm saying why, but let's go there. Let's go there. And we're gonna have a signal. One of our first signals. We have the method info with on new chunk. Is that it? Can I just do this? Oh no, wait, I have to put like some variables and stuff. Right. So like property info, variant, what is it gonna be? Observer chunk. Object. Like well, node. No. Object. Wait, so the first one, oh, we have the name. And this is going to be something like chunk. Old chunk. Well, that's the observer, right? Okay. Current, well, olds and new. Old chunk, new chunk. Can I specify your type? I'm kind of curious about this. Oh wait, it has to be, yeah, closed. I mean, of course. And this one too. Hey, okay, it's a bit better. Interesting. Why is it making me sleep so much? Expected what? Yeah, I wanted to check what was inside property info. And what is... So I forgot one of those. No, I did not. No, I didn't. Can I restart maybe? And before I restart, maybe I want to set the player in some place. Repairment, add child. I don't know if it's possible. I'm sorry about that. I really don't know if I can stay awake. I can't think without going down like every 3 seconds. Oh, maybe I should just do nothing for today. A shame. Maybe I'll be streaming tomorrow morning though instead. Since I mean, if I go to sleep early, then I wake up early too. Okay, why do I have the shader file? One, two, three. 1. Oh, it's there. I missed it here. And then you have this. And I guess that's it. This one is fine. Fine. That's fine. Okay. I don't know what's wrong. I don't know what's wrong, but okay, we have all of this. Not bad. And we could have unmoved, for example. We could have other things, I guess. But yeah. What about something like collisions? I can't think. I can't think for any of that. I'm thinking down. What was my latest priorities? Place the block and destroy it. It's done. If the chunk is modified during runtime, yeah, there's like optimization. I actually want to make this one because I want to split my very big loops inside cube chunk fissures. Like this. We can basically have like a massive optimization that becomes O1 instead of O everything. So I'm just gonna go with it. Well, I mean, we can basically pass it on the GPU. But another thing I'm gonna do is I'm gonna go to where the vertex is generated there. Here. Oh. Okay. Okay. Whoa, that was weird. What was that? Okay. So we have all of this, right? But when we destroy a block, we don't want to regenerate everything, right? Would be a shame. So instead we can split this between the vertex generation and stuff, and between the faces that I actually want. So it's gonna add a vector temporarily, but it's fine. It's fine. So basically this is going to filter faces. That's the goal. So you have face index, normal. If it's inside the chunk, well, not inside or not opaque, then I don't. Well. Yeah, if it is... Huh? Cube chunk. Oh, right, I have to implement... Normals. Yeah, so we have the new block, right? We have the neighbor block. I guess I have to optimize a bit for this too. Like, I have to communicate with the other chunks about this. And... is in chunk, get block index. I mean, I can reconstruct the block from the indices. Okay. So... Oh. The blocks and the detection. To do if not in block. If not in block, check. Oh right. Neighbor chunk. Yeah, there's actually something else I wanted to do. Is I have to check the neighbor chunk, so I have to be able to access the other classes too, right? And I mean technically I have like an array of neighbors somewhere. Actually, maybe not in the visual. My bad. But yeah, in the model, I guess we do. And that should be sufficient. But what I'm actually gonna do is I want to make a class that's gonna be some kind of builder that's going to generate the vertices and stuff. And the reason for that is that this way I don't have to have a lot of arrays that are not optimized with their size. And by reusing the same arrays in the same builder, then I'd be able to do what actually? To prevent reallocations. So it's a bit more friendly. And yeah, I would say that's it. Okay. Then we have cube chunk space. Wait, that's in... Where's that? Rendering. Should we put that in rendering? Because it's about faces, right? I mean, if it's about faces, then... Oh, I guess collisions might want to use it too. So I'm gonna make the new class in core, probably. Let me think. Sounds like a good idea, actually. I guess everything is just gonna be in core. I guess the visuals are really gonna be about the rendering API. That way it should be good. We already have the loader here, so it shouldn't be that different. We have the loader. I'm just gonna copy this. Instead of a loader, I want... What did I want? Wait. Face builder, right? Face builder might be fine. Or like chunk face builder, something like this. Cube chunk, maybe in this case. Yeah, I mean cube. Yeah, let's go with this. Well, cube chunk face builder. Here we go. Okay, here we go. And then we are going to move that to core. Because it's surprise core. I guess I can put a pragma-ons. I really have to start replacing. Because last stream where I was talking about this, it was a bit embarrassing to see that Godot was actually using it everywhere. I thought it wasn't. Chunk loader, no, it's cube chunk base builder. And we're just gonna go there. Here. I guess this one is not that bad. Okay, so then we have different functions. We actually don't have the important one in protected, right? And then we have a lot of problems there. I mean, that's fine. I can just remove this. Cube chunk face builder. So how are we going to? I guess we want to have a list of vertices and things, right? And that's going to be request faces, for example. And it can become multi-threaded. So that would be good if it was multi-threaded. So request faces. Okay, and I guess we might want some kind of callback, maybe. So we might have a cube chunk visual. Are we? Actually, just never mind, because we might want to use it for collisions too, right? So it's just going to be like a cube, cube chunk. Something like this. A cube chunk? I guess it is cube chunk. Okay. Right. So we have the chunk. Do we? Face builder. Yeah. Okay. And then it's basically going to be here. Or is it? Add observer. Let's do just that connect this. It shouldn't be this, but you know, it's like, okay. I'm gonna see the error basically when I try to compile again, so that's fine. And I'm gonna know what I wanted to do. So we have the request faces. And then we want to loop around all of this cube chunks visual. So you can basically copy a lot of things here. If not in a block, check neighbor chunk. And is there else? There's no else. So what I might want is, if it's not inside the chunk, I'm gonna look to the next chunk. So I guess I need a reference to the space or something like that. Would be nice. Like here. Chunk space. Null by default. Haha. I know you gotta. Well, chunk space. Yeah, it's there. Okay, we have this, and when we request, we have the chunk. And if I want to generate things right away, I could do something. Let's include for now. Modules, voxel, 4. Cube. Yep. Visuals. Chunk. Wait. Right. Wait. What was it again? And I guess I don't even have chunks right now. Wow. Do I want just a chunk or a cube chunk? I mean, maybe just a cube chunk for now. Well, a cube chunk because we can do more. Can it open? Yes. Okay, let's do this. Again. Huh? Face chunk. Yeah, that doesn't exist, that's why. What? Huh? Huh? Oh, right, it's itself, right? No, it's not itself. Cube chunk face builder. Face chunk. Yeah, okay, see. It's the same. So then when you do this, what am I gonna do? I'm gonna get the space. Am I? Right, I guess I have to include it. Oh, thanks for the raid. Oh. Le Sony. Thank you a lot. Let me give you a little shout out. How are you doing? How has been the stream? Thanks for the raid. Yeah. Yeah. Nope. Not this, actually, just this one. Hey, what's good? Making some progress on my game. Oh, great. Wanna see what I'm making right now? It's incredible. I can show you. I have the editor right now. Basically, there's not a lot for different reasons. But basically, we're inside the donut. I mean, that's like kind of... oh, that wasn't even in the name. Yeah, basically, we are making a donut, so like it's generating slowly right now, but it's gonna complete like this. And I can go in the ground, and you know, we have like cubes, right? We can put cubes, we can destroy them. And like, for example, if I have this... Thanks for the follow! And yeah, if I do this, for example, and place a lot of cubes... I should make it so when I keep the right click pressed, it just spams. Because right now I'm just right clicking myself every time for every block. But yeah, if I do this, for example, you can see that it's actually curved. Right? Like when I move, it's actually curving. But locally, it stays flat, right? Mario Galaxy Minecraft, kind of, yeah. Heya! Welcome! Like this. And yeah, basically we have this. It's like very, very weird. Because also donuts. Yeah, you can see that the donut is kind of finishing right now. We can also loop, right? Around the donut like this. And you can see that we're just gonna see the donut again. I'll go back to where we were before. And here we go. Whoa, that's awesome. Thanks. And now I'm gonna open Paint for you. I'm basically just showing you the kind of how it works behind. But you know, when you have a donut, it looks like like this, right? And the thing is, here you have like a circle, right? Like for example, here you have like a circle. If you like cut the donut where my stone is, and if you cut it where my stone is, you have this. Okay, well, you have this. But the thing is, right now, look at this. This is like incredible. If you go down, you know it's cubes, right? Okay, I can't destroy this one. It's like magic generation, but it's like there, right? It's good. It's fine. You can continue to go down. You have like the bedrock. Okay, that's like this one. We can continue going down, right? And then this is the final bedrock, because if I continue to go down, I'm basically on the other side. Like if I press shift, I'm actually going up now. Like if I try to go down, I'm actually going up. Like it's inverted. Because I just went through the donut. But it's squared, right? And if you look at this, you have the donut. If each block is on top of another block, basically you're supposed to have something like this, right? But, you know, like you have a cube, you have another cube on top of each other, right? But wait a minute, there's a problem, isn't it? It's slowly becoming like smaller and smaller, right? Well, wait, so do you have donuts inside the donut? Well, right now I do have like, right now I have like one donut, like this donut, inside inside this donut, inside this donut. Right now, it was actually some kind of bug with the generation. I have to take that into account. But yeah, for now it was very useful because it allowed me to debug some things like underground, like when you had like a bunch of free space underground and, you know, like some blocks above your head. That helped me debug that. I have some problem with the first time culling, as you can see, but it's fine. The reason is because I basically made my, well, I have some distortion, so that's why it's like bugging with the first time culling, but I also made my own custom render pipeline, so that's why you also don't have any shadow right now. I plan to add this back though, and I plan to work a bit on the rendering, but I have some priorities. Right now I would say the priorities are probably that, like generating the chunks around the player first. Add back collisions. Well, basically I have collisions, but I disabled them because it's taking some... Well, they're not updating, I would say, right now. Like when you destroy a block, for example, well, you can't go through it, so I have to handle this. I guess small optimization, okay. I want to start making like simple biomes, and maybe like a very small dungeon, and, you know, start making some gameplay. Then I want some, you know, nice rendering, or like better with like the occlusion, for example, the ambient occlusion. I'm not sure about this, maybe. And I want the multiplayer, because I think as soon as I have like the multiplayer with some base gameplay, it's gonna be kind of interesting already. Like I could make it like, I could put it on Steam and have like some beta there or something like that, like give keys and, you know, just have fun with some people. And yeah. And yeah, the thing is, as I told you, it's supposed to be like smaller and smaller, right? And I mean, I can show you the actual transformation. Well, without the transformation. It's like pretty crazy. If I do, for example, distorted, pushed, hot space, this one. If I do this, reimport, and I run it, we're going to see a donut. Well, let's go up. So we have the donut that is getting generated, you know, correctly right now. And if we go there, we see that it's actually rectangles. And if we go down, let's go down. We can see that the rectangles are actually very rectangular, let's say. And if you dig down, it's basically becoming like smaller and smaller. And then we have like, we have those rectangles. So this is basically the default. Like if you have a donut and you want to have, you know, like if you want to subdivide it to make cubes on top of cubes, it basically turns into rectangles like there, right? So yeah. Right, like it's very, very weird right now. But you know, like it's kind of normal. But yeah, I have this distortion that fixes things. Where is it? Here. But yeah, that's it. And yeah, the goal is to have vehicles, like for the player to make vehicles, to craft his own vehicles, to craft his own weapons, to make like a spaceship, for example, go into space, go to different planets with different geometries, have like some kind of RPG, like dungeon RPG side, and what else? Yeah, have like giant creatures, like big creatures that are made with chunks, maybe like a giant turtle on which you can go on, walk on, and like build a village on top of it, and the turtle is gonna move. I really want to make that turtle. It reminds me of the grid mapping onto a sphere, like they do in Dyson Sphere program when you build on a planet. Yeah, a cube sphere. I looked into it a little. Like this, right? Around the poles, the grid gets weird. Well, it's not really around. Well, for cube spheres, it's not around the poles. It's around the vertices of the cube. But if you're talking about the poles, then it's about the UV sphere. This one has problems around the poles, right? Because of this. Or something like that. I don't remember exactly how it was mapped. Yeah, I see. Yeah, if it's the poles, it's the UV sphere. If it's the vertices of a cube, it's like the cube sphere. Like the advantage is that this one is, well, always has quads, you could say. But this one has like triangles towards the pole. So it's like very distorted. I might want to make a planet that's like this actually. And I want to make I want to make non-Euclidean planets also. That's why my code is like a bit weird right now. It's because it's trying to account for like different geometries, like impossible geometries. Because right now, for example, you know, like there's my donut, right? But you know, there's like an inside to my donut, right? And there's an outside, like this, right? But the thing is, since everything is Euclidean when it's close to me, and my speed is the same relative to those blocks, right? That means basically whether you run from the inside or from the outside, the duration to complete like the circle is the same. So that's like pretty funny. Like for example, let's say you have inside, then you have the outside. Like we can make this like bigger, right? We can make it like this. Right? Whether you go like this or like this, the duration is the same. Which is not, you know, something you would think at first, right? Because it's a donut, like the distance is less, right? But since locally you only see cubes, and the amount of cubes is the same, well, it just leads to that. It's the same distance. So that's kind of funny. I also want to make donut where you can just dig down forever, even though the donut is limited in size. But yeah, different, like a different crazy things you could say, like digging down underground, for example, and just ending up on another planet. You can make it possible. I can make anything possible. So let me go back to what I was doing. When there are chunks, yeah, if you have any question though, like if you're interested into anything, feel free to ask. Digging down into a portal. Well, it depends how you... It wouldn't necessarily be a portal. Because it depends on how you generate the chunks too. Because like in Minecraft, chunks have coordinates, like XYZ coordinates, right? But what you can do is you can also map a chunk into another chunk that is different, let's say, right? So, like portals is actually, you only have the notion of portal if you're in Euclidean geometry and describe a teleportation by some kind of global coordinate system. But if you don't have a global coordinate system, then you actually can't say that you have a portal. Which is the goal. Since I want to account for different types of spaces and I want a large world, and that means I have to take into account float imprecision when going far away from the origin, because that's why Minecraft is bugged, right? Like that's why there's an actual limit to Minecraft, because there's a limit in float precision. But basically you can fix that by recentering the world around the player. And that means coordinates are only about local... Well, in my case, you would have different planets. And each planet has its own coordinate system. So for example, with the donut, it would be, donut coordinates, like with the angle, well, 2 angles and the eighth. But like with a sphere, it would be like, well, actually two angles and the eighth too, right? But you might have something like a planet that's like non-Euclidean, and it will be a bit different. Or, that kind of thing. Or like a planet maybe that's like a cube, you could think. You could say, like a planet that's flat, for example. And then you would have like Minecraft's coordinates, you could say. Like you kind of have different kinds of coordinates. And yeah, I guess you could just hop from one to the other. But that's actually a question. That's actually something I thought about myself. Like, can you say that a player is teleporting if it's changing coordinate systems completely? Because a teleportation is about, in the same referential, going from one coordinate to the other, right? Like, for example, from 0, 0 to 10, 5, right? Teleportation. But if you go, like, from the top of a sphere to the top of a torus, like, the coordinates are completely different. And it's like you could say it's like a bit like a different world. But yeah, it's a bit complicated. You could say it's probably a teleportation, but yeah. And we want to generate chunks around the player now. So, space. I mean, actually, do I really want this? Maybe I don't, because things are working pretty well as they are right now. So maybe that's just going to be... Oh, but no, actually, collisions are going to need that too, so I'm just gonna continue just a little. I think teleporting is either you would change coordinates instantly or change the world into another world, even if it has the same coordinates system and coordinates. It will still be a different world. Yeah. If it's a different world, then you're right. That would like make sense. I mean, I guess a portal would maybe technically not be teleporting, but just traversing through space. So yeah, it would. Yeah, it would. You're right. You're right. Like, do you know about non-Euclidean geometry? Can I show it? What was the link? JLPT, no. GitHub. Okay, maybe I can just type it. Non-Euclidean geometry. Or maybe this. Sorry, what did you say? Do you know about non-Euclidean geometry? Maybe I'm pronouncing it wrong. Well, wrong, but yeah. Sorry for the accent. But yeah, it's something, I guess it might not be very known, but it's something very funny that I love a lot. Oh, yes, somewhat. Never did any projects with it, but watched some videos on it. Great. Basically, I want to have some worlds like that. And you know, like you can have because I guess it's still keeping some fundamental geometry axioms, you could say, but you can also anyways. Yeah, basically I was trying to, well, yeah, I wanted to implement some of those transformations, like basically everything that finishes with q equals 4, like 5, 6, 7. I want to do that because in the corners it looks like this, and you can have like cubes there, and you might be able to fill this with cubes. And there's also this one that's like really neat with heptagons. Optothorax on YouTube did some videos on portals that are kind of insane. Maybe I know this guy. Yeah, okay. I definitely know this guy. Yeah. Watched. Watched too. Yeah. Yeah, I agree. It's insane. It's like pretty neat. I'm like a lot into portals too. Non-Euclidean geometry portals. Yeah, I basically want portals too, I guess, into my in my world. I want to make my world like very like a technical gem, you could say. And yeah, that's it. Cube, that builder. Wait, what was this for again? Request faces. Well, I gotta go now, but this looks awesome. Thanks. Good luck with your stream and your game. Thank you, thank you. And yeah, see you next time maybe. And thanks again for raiding. Yeah. Wait a second. I don't remember why I was trying to do that right now. I mean, it's like it's good for like optimization and stuff, but it's not really needed though, is it? Chunk visual louder. On new chunk, no. Wait, what? Right. So then I have the observer. Add signal. And this is expecting something. Oh, right. Like this. Hey, here we go. So on new chunk, how can I bind the signal? Godot CPP bind signal. Add signal. Emit signal. Okay. What about the binding though? Connecting. So it's on head tang. This that. Oh. Wait, what? Can I just do that? Can I just do that? Oh no, that's GD script though. That's why. No, I want to connect in bind signal in CPP. I want to bind it in C++. Is it using a collabel? Oh no. It's not using the same. Registering a custom signal. Okay, yeah, this is the one I want, probably. But how do you connect? Okay, you can emit it, but how can you listen to it in C++? Nah. Class DB bind method. Oh, wait, what? Oh. No, that's not what I want. Do something. Oh. Wait, what? So emit nana, my custom signal. So you emit. Unreceived. But how do you call this? Well, bind this. Oh, here. Bind method. With the signal. Oh, it was hidden. So wait, what? But it's like dynamic, right? Binds the receiving callback function. To class DB so Godot can see it. What? I don't really want Godot to see it though. Maybe I can just use my C pointers and stuff. Maybe I can have this. What about? Well, I want like an array though. It doesn't. I don't know if it's like optimized. C++. Wait, disconnect. Wait, this is it. This is it. Connecting the signal. Never mind, this is it. Using a string-based collab. Ooh. Okay, I might want this. Ah! Okay, this is good. Let's close. So we have this. We can go in the observer. Maybe not. Wait. We have a signal, okay. So here. This connects. So from the observer, we want to connect this signal to... So I guess it's going to be a callable anyways. Well, to this. And it's going to be this. On observer new chunk. Okay. So we should have connected this, which is good. Can I have like a onth, like add flags? Yeah, we do have flags. Perfect. So, oh no. What are the flags? Connect persist. Right. Oh, so it's connect one shot. In my case. Is it? No, it's not. No, it's not. Okay, this should be fine. And when we remove an observer, we want to remove it though, but that's fine. Do I want to make that function right now? I'm not sure. Anyways. Oh, wait. Yeah, let's do that when needed only. So we connect. And I guess we get the current chunk and push this back. Wait, it's actually never in my list of observers. Okay. Well, I don't have a list of observers there, I guess. That's fine. And when it goes into a new chunk, I guess I want to clear every chunk. And I mean, I want to... I'm not sure about that. How is it called when you have a list? Skip list? Skip list? Wiki? Yeah, it's called the skip list, right? Is it? Probabilistic. Ew. Probabilistic. Yeah, basically I want something like this. I was thinking, but instead of dividing this, let's say, I want my... I actually don't know. Wait a second. I guess I want the list of chunks that has not been generated yet, that are around those that have been generated. I mean, I guess it's fine as it is. Is it? I don't know. Might be. Maybe I don't want to clear everything, really. But yeah, I also want a list of observers, because the problem right now is that it's going to... I don't know, actually. Do I want a limit of chunks? Because right now I'm generating everything, right? But maybe I want... yeah. I want some kind of distance from the player. So I guess instead of like the distance in radius and stuff, it's going to be in nodes. So I'm gonna have like some kind of jigsaw. But that might work. And I run the jigsaw every time the player changes chunks. I'm not really sure about this. But well, or almost, I guess. Like in 3 times 3, it's like 0, for example. Anyways. Yeah, that might be actually nice. Should it? Well, no. I mean, I feel like I'm going to have to go through things again. The chunks. Yeah, I mean... I can always have it through multiple frames. But I do want a jigsaw on the chunks, I guess. So on observer new chunks, so we can request a new chunk. And it's from... Okay, and yeah, this is from one chunk. Oh wait, I actually don't have chunks to spawn from. Is it really what I want? I mean, I guess that's fine. And in the end, we have chunk to load. Okay, this is the one. And chunk to load is from a specific chunk. And we have the specific face, right? The neighbor. So we want a graph that loops through things and through different chunks. So we are going to have the chunks it generated from. And then we have the face because it's going to be null in, well, for the neighbor that is null. Because it's a graph. So we can have like some extra. Maybe I need some class for that. But yeah, I don't know. Well, I mean, I was starting to make a builder or something, but it's actually not very... It's not actually required right now. It's not necessary. I'm just gonna keep this, I guess. Oh, and this one needs to be somewhere else. Cool. Yeah. And yeah, Jigsaw. Let's go with Jigsaw. Like pathfinding, maybe. Core, inside core. It's not really pathfinding, it's like search. Yeah. And we can have Jigsaw. I think that's how it's spelled. No, it's not. Dijkstra. Right. Dijkstra. I can't spell it, I'm sorry. I can't say it, pronounce it. So we have this. Dijkstra. Chunk Dijkstra, maybe? I mean... I guess so. Oh, can I... I guess that's fine. Okay, so core. Touch. Then we have for such. Here we go. Dijkstra. Hey, here we go. And chunk Dijkstra. No, you're wrong and you're banned. Well, we. Oh, hello, me. Pretty nice voice you have. Okay, so we have all of this. We have the chunk, the start, I guess. And I mean, Dijkstra is a search, though, right? I'm not sure about this, but okay. Can I? I was thinking about like I was wondering if I had a way to add data to a chunk easily or not. But I guess it's fine if not. Wait. I mean, I guess it's gonna be a component, a component system. If I have this. Yeah, never mind. Forget about this. So chunk. We have the start, right? And then for every chunk, we're going to have some data. So maybe it's going to be like a map, like a dictionary, like a hash map. A hash map. Hey, hash map. And it's gonna be from a chunk to something a bit more stylish. Like a chunk data. Hey, Dijkstra data. I mean something, right? We can also have the class here, really. Maybe not private, but chunk data maybe. Why is it so weird? Right, because of this. Okay, good. This is chunk data. Is it? I mean, if it's a class, maybe it's gonna be a struct. I don't know. Wait, is it optimized for insertion and stuff? Very efficient in terms of performance and memory usage. I guess it is. Adding elements to the end of the array. Oh, okay, like that. Well, I guess. Allows you to access array elements by their index. Yeah, I'm not sure about this. Anyways, so let's say we have this. Do I actually want... So basically I'm gonna have like a depth, a specific depth for each chunk. Right? Like depth, maybe not depth, but something. I mean, I guess I could have like some cost and stuff. I have to think a little what is happening. Okay. So we have the start. I go around. What's the goal? I mean, I guess it's the maximum distance. So maybe we want something like. Is it going to be a node? I'm not sure about this, but we're gonna have like a max depth. Maybe. We're gonna have a generate. And we can get the chunks around. So let's say we do the Dijkstra, we have all the chunks around. Then that means visual loader. That means this is not needed anymore. Like this, with the callback and the loop like this, because instead we can just yeah, basically that's going to be useful, because right now I have to generate the chunk that is the closest to me before generating the one that is after, right? But the problem with that, oh wait, it doesn't exist, that's why. Oh, that's the problem. But yeah, the problem is if we want to make some chunks appear first, like the ones that are in front of me, instead of like on the sides, it's getting a bit complicated. Actually, it's still doable, but yeah. So spawn visual from chunk. So I was thinking about gathering chunks around and then sorting them depending on their depth, for example, which should already be sorted. Maybe I have to. I was thinking maybe I just want a function instead of all of this, and like lambdas and stuff, or like a templated class to inject my own callbacks functions. So like, for example, maybe not templated. For example, we have this, we have go through loop. How can I call this? Loop. Travel. We can travel like this. And the extra is basically, wait. It's basically a queue, right? So in Godot, it's vector A, local vector would be the best. Or I guess if I make it like a singleton, I can reuse the same arrays to prevent dynamic allocations, maybe. But anyways, let's just keep this for now. So we have chunks to process, maybe. I'm gonna push back the start. I mean, yeah, I guess I'm gonna keep this inside. That's fine. Then what I'm going to do is, I guess I want to pop the first element. Or do I? Maybe not. Oh, right, there's an index. I don't... Yeah, I'm not forced to pop the first element. I just have to ignore it. So index equals 0, while index is less. Yeah, that's right. While this is less than the size, that means while there is still something to process. So at first it should be 1, right? The size is 1, so 0 is less than 1, so that should loop. And while this is less, I'm going to get my chunk index, and I'm going to include it. Modules, voxel, core, chunks, chunk. And then I'm just going to do well, get the neighbors, right? Get neighbor. Ooh, I'm not sure about this. Actually, am I? It's just a reference, so actually, yeah, I am. So I have the neighbors. And I also need a list, though. I need a list of the depth for each chunk. So I'm taking a data-oriented approach. How do you call that? So you have OOP, object-oriented programming, and data-oriented programming. Data. D-O-P? That's dope. Wait, that's not that. I don't know. So we have the neighbors. Two neighbors. Here we go. And I guess I want a flag for each one, though. Oh, that's a bit troublesome. Is it? Can I just have I'm not sure actually. Yeah, it seems kind of problematic. For like performance. Like I would love to have a boolean inside in each chunk, but that's not really possible, right? I mean, I can have like a metadata system. And that way it would be like very optimized. But yeah, but yeah, let's have it is. Because metadata would mean string name, for example, would mean a way to make things kind of right. Oh wait, what if I have a pointer instead? What if it's a pointer that I can make it point to different kinds of data? So I can retrieve my things in O1. But that would not be thread safe though. But that would be a way to have things in O1 pretty well. And like constant access. Like without like, you know, the hash, for example. That would be an idea. That would be a great idea. Okay. So I have the neighbors. Let's go through the neighbors. For chunk in the neighbors. So this one is well depth. I just wanna push back, I guess. And it's gonna be maybe index. Is it? It's not, right? It shouldn't work like that. How am I going to increment each time and not for each chunk? I mean, maybe if it's null, then I increment. Oh, that would be a pretty neat way to do it. And depth, do I need to? Oh. Wait a second. Depth. Oh, I can have things. I can represent things in a totally different way. And I would be able to get the chunks for a given depth, which is really nice. So basically this is going to be depth 2 chunk. And it's going to start at 0. And like if I want to get the chunks that are of depth 1, then basically it's going to be like I go to 1, like I access this at 1, and that gives me a number that is the index in chunks from which the chunks are at depth 1 or more. And I can have like well, basically, yeah, that's crazy. So basically what I want is a pushback 0. First chunk, well, chunks at depth 0 starts at the start, right? Then I loop, and I was thinking maybe we can have some of these be null. Let me remove this. So I'm just gonna push back chunk. And I'm just gonna push back again with I mean, I guess technically I should not need the nulls, but how can I optimize it so there's no null in the array, and so that I can keep the integers. Well, keep the integers. Know about the depth. Actually, I can just add another integer nb chunks before next depth. So I guess if we start at 0, then it's going to push back right away. Right. Oh, wait a second. Yeah, it doesn't work with... Oh, it doesn't work in some circumstance. Well, does it? Actually, it does. Yeah, but... Oh. Okay. Okay, I had a nice algorithm. But it doesn't work if, like, the space go back to itself. Like, there's a teleportation, like, if there's a portal. It would work for non-Euclidean spaces, that's what's crazy. But not for portals. Yeah, yeah, let's put some additional pointer here. Should we? I think there was like a thread local. C++ thread local in class. I don't think you can do that, but declared inside the class must also be declared as a static. Oh, that's why. Yeah, that makes sense. Static? I don't want it to be static though. Public. Yeah, let's just go in here. Like maybe here. And it's gonna be custom data. Used by algorithm for O1 access. O1 constant access. Not thread safe. Can I have it be thread safe actually? I mean, I'm probably going to custom data. Maybe I can make a new one for each algorithm. That would be kind of bad. Yeah, let's just have this for now. Which... Okay, let's just do this. So we have this. We have the start. We have custom data equals. So it's a void star. It's gonna be 0. I guess it's gonna be this. So this is gonna be 0. This is gonna be an integer. Then I push. Let me think a little. Death. I mean, everything is relative though. What if I want to multithread this? Huh. I mean, I guess... Oh, that's gonna be... If it's null, then it's like the same as 0 though, right? So maybe I should like start at 1. So yeah, now there's a problem. Oh, surprise. Something... I mean, of course I can't have this. Let's just have this. Or like... I'm not sure. I'm not sure. I can optimize it for cubes. That's kind of the problem. There's like a lot to optimize. Let me be right back. Small break. Okay, I'm back. Back. Here we go. So, what can we do? What can we do? Chunks, fishback, and because if I execute this like very often, I don't want it to be slow. So that's why I was kind of, not sure about this, but at the same time, I don't think I have to worry that much because I can have like specializations. Like if I'm in a non-Euclidean world, I don't need a very far chunk distance. And if I am in... Actually, it depends. Well, okay, never mind, it depends. Okay. So, what should we do? Chunks pushback. Let's say by default it's something. This is gonna be 1. Custom data. Yeah, let's say this is fine. Then we, if this equal null, I guess it should be null by default though, right? Should it? I guess it should. I'm not sure now. I mean, if I have to reset everything to null at the end, maybe it's kind of the same I was gonna say, maybe not. Okay, if custom data is null, then I push back, right? Or do I? Wait. No, okay, wait a second. No, okay. Wait, if it's supposed to be a travel, I don't want to push back, right? I want to call a function. I want to call a function. And like if this equals 0, I actually think amount of neighbors, maybe not, because it depends on this too. Actually, is new depth. Like this. And if it is, then we have the pushback. Pushback? Wait, no, I don't really want to pushback though, right? Wait, why? Yeah, because I want to process. Okay, I want to process them. Never mind. I guess I don't really need this, though. Okay. Custom data. I'm not sure about this one, Eva. If it's a new depth. I guess it's just current depth. And I plus equal 1. And maybe I have on new depth that might be empty and might be optimized away. So you can have this, the new depth. Oh, so that means I can actually put things like here. Well, things. I just put the chunk there. And I can remove this. Can I? Well, never mind, that's stupid. That would be stupid. Yeah, okay. It wouldn't loop if I did that. I guess the array can also be like from the outside. If you want to get it. And current depth, if it's new, then +1 on new depth. And the amount though should be plus equal something. Should it? Yeah. NB I'm not sure. Should be fine. So NB chunks, NB currents. Well, pre I'm not sure about that. Let's say we have a few nodes that have been, a few chunks that are being explored at the same time. Yeah, it would be bad, wouldn't it? Or would it? If it's 0, then I guess it's actually NV chunks before, well, next depth index. And instead we can have index equals this. And this is just gonna be current depth plus equal 1. No? And when I do this, I plus there. Push back, chunk. Yeah, I push back. Then it's pushing, then it's pushing, then it's pushing. Oh yeah, that's the current. Okay. So we have this, and the next depth index is the current chunks of size, right? Yeah, should be good, I think. And this one should be called on chunk processed, on chunk traveled. We have the current depth, and we have the chunk. And I guess I might want it for the first, well, for the start too, right? I'm actually not sure about this. Maybe not, I don't know. Yeah, maybe it can just be something here. I don't really need all of this, do I? Well, actually, kind of, it seems. A template. I mean, a templated class might be better. So like if I don't have this, I guess, and just have type name T, chunks Dijkstra. So I don't have the GD class. I don't have this. Find method, nope. It's public. And now I go to the surface, let's say. I mean, I already have surface though. But yeah, let's just have something like this. Okay. The travel. Okay, we have this. Now we go here. We have all of that. We have the, I guess, out chunks maybe. And I can have callbacks that, for example, update an array with indices. And that way I can have like very custom things, which is nice. Custom data. So yeah, thanks to that I just never go back. I'm not sure about the null pointer. I could have like a small hash map, for example. But yeah, well, hash set, I guess, of elements I've checked. But I guess I like that for now. It's not, well, out chunks. Well, actually it's supposed to be a class, right? So let's keep things inside the class. Out chunks. Well, processed chunks sorted in depth order. So we have the start. Maximum depth. I guess I can break. Yeah, because it's never gonna finish, right, in some worlds. So end index is less than this. Less or equal it could be, but yeah. Yeah, let's say less. Removing this. On chunks traveled. Wait, process chunks. I'm lost. I'm not really lost, I'm just tired. Okay. On chunk traveled. Do I need to... Actually, it's just process chunks, right? Yeah, just this. So we have all of this. We're also going to have templates to find stuff. So on new death and on chunk travels. I mean, everything should be public, really. It's just a helper class. So it's gonna be type name on new death. I mean, I guess I need this to be... Wait, what is T? What is T? There's no T here. That's not my cup of tea. Okay, so what if I do this, and then I just have the callbacks here instead? Like template, type name. Type name on new death. And then on chunk travels. Wait, where is there? Oop. Like this. Now we can have the template there. And we can basically loop multiple times, but by setting different things. So that's kind of neat. I mean, if I want to add more things, I can just, you know, loop through the list, but, you know, that's how it is. Well, what? Oh, right. This. Okay. It's done, I guess. Dijkstra may not have a template argument list. Does it not? I guess that makes sense. Yeah, because they're already on top. It's not a specialization. So it's fine. So now I can go back there. And I should be able to do something like on new death. And the new death, I actually don't even have it. Wait, yeah, that's normal. Ooh, what was I even doing? Oh, yeah, I have to pass this as an argument. So on new death, for example. And same here. On chunk changed, you can say. It's like a bit different from how I called it before, but yeah. And then I'm just going to call this and call this. And I guess that's it. Compatible. There it is. Oh, I don't need this. Yeah, sorry, I'm like dying. I don't know how I'm still able to stream. But you can see that I'm just falling asleep every 2 seconds. So yeah. Wow.
Like the bat outline looks smaller now.
Yeah, let's just Let's go with this guy. And thank you everyone for watching. And just see you tomorrow probably, when my eyes are a bit more open. We still have so much to do, but should be alright if I sleep well enough. Incomplete function. Is it? Right, it is. So I guess I want maybe I want right value reference, but that's fine. I can have this. I can have this inside the function signature. And that's why I can just, you know, do things, and this is good. And this is good. It's like templated, so it's like static, well, not polymer, well, yeah, actually. Unchunk changed. Yeah, there's nothing to give more than that. Yeah, okay. Okay. Thank you again, everyone, and see you next time. Ooh.